Lesson 4.5, and by the way, I guess it's obvious that we skipped 4.4, but 4.4 is dealing with larger systems, systems with 3 equations, with 3 variables, x, y, and z, and we just don't handle that kind in here.
Thank goodness.
We're going to look now at how to use some of these systems to help us solve some problems, okay? What we're going to do is we're going to translate the word problem into 2 equations. There will be 2 complete thoughts, probably 2 sentences in each one of these word problems. Each one of those is going to give us an equation. We're going to read it, we're going to write it. Then we're going to decide on graphing, substitution, or addition. And I would say that we will not choose graphing, because you have to know that the problem's going to work out really nice and that the numbers are going to be small enough, like less than 10, to fit in your grid. And there's no promise that that's going to happen in these problems. So I would say we're not going to use graphing as a technique. But you will look at it and say, do I want to use substitution or do I want to use addition? What will help you make your mind up? Substitution, does it have the form x equals or the form y equals? Or with addition, does it have a pair of opposites, or would it be easy to make a pair of opposites? So that's what I'm going to use to make my decisions. Problem number 1 is may be a little challenging for you to actually read, but that's why I sent you an email and asked you to print those. Okay, number 1, it says, and I'm going to read it out loud, it says, without actually solving the problem, choose the correct solution by deciding which choice satisfies the given conditions. Okay, now we are going to practice doing some translating. I'll read the whole question now. The length of a rectangle is 4 feet longer than its width. The perimeter is 28 feet. Find the dimensions of the rectangle. And I have part of this cut off the screen for those of you looking at it in the class. All right, the first thing you must, and now you might have gotten away without doing this back in chapter 2, but now it's going to be critical. How many unknowns are there? Right now there are 2. They are length and width. So I need to start out by saying L is going to equal the length. That would make more sense. And W is going to stand for the width. Now, if you want to stick with X and Y, you're welcome to, but it seems to make a little more sense to me to use those variables here. All right, now I'm going to write the 2 equations because we need all the practice we can get at translating. Every time I mention the concept of length, we write down L. Every time I mention the concept of width, we write down W. Okay, what does it say? The length is, now what always happens at the is? Okay, so the length is, L equals 4 feet longer than the width. Okay, 4 longer than. That's the same as 4 more than. So it is 4 plus the width. Do you agree that that's what it says? The length is 4 more than the width.
Wait, right. So why wouldn't that be multiplication?
Because it didn't say, it would literally have to say 4 times.
Oh, okay.
Okay? More than always just means plus. All right. The other statement, I'm ready for a new equation. It says the perimeter is 28 feet. Perimeter. How do you find perimeter? You add all the sides, right? Do you agree that it could be L plus W is 28? And many of you already know that, I really don't have to write it like that. Isn't it 2L plus 2W is 28? Whoops. Okay? And even if you were a little iffy on that, next time you encounter perimeter, you would know that it's twice the length plus twice the width equals the perimeter for a rectangle. All right, now, we're not supposed to solve this. We wanted to practice the translation, and now what we're doing is we're checking to see if answers are logical. Now, this might be a little difficult to read, but the first one says the length is 9 and the width is 5. I just want to see if those meet the conditions. Is the length 4 more than the width? Yes, okay. 8 and 4. Is the length 4 more than the width? 8 and 6. No. So right away, I know choice C is not a good one. Now I go to the second condition, which was the perimeter is 28. Well, if I use the length is 9, well, 2 lengths would make 18. 2 widths of 5 would make 10, and that equals 28. That's looking really good right now. Let's look at B. 2 lengths would be 16. 2 widths of 4 would be 8, and that's 24. Is that what the perimeter was supposed to be? No. This is our choice. These numbers meet both conditions. That's what you were supposed to realize from that problem was, how do you translate? A little bit. And the answers are correct if they satisfy both of the conditions from the problem. That's all you were supposed to get out of that problem. Let's look at number 2. Maybe. Okay. Please, could I have number 2? No. Oh, it's there. All those ones that I hit. It was just a little slow. All right, and I'm not 100% sure why this showed up in blue, but it's in blue. In this problem, all we're doing, and I'll read it out loud because I know that for y'all in the classroom it's hard to read. It says, write a system of equations in X and Y describing the situation, do not solve the system. So all we're doing now is practicing translating. That's it. All right, it says, Kiko has a total of $5,100, which she has invested in 2 accounts. The larger account is $900 greater than the smaller account. Let X be the amount of money in the larger account. All right. Now, usually you decide which one is larger and smaller, but the author of the problem told us. You let X equal the larger. Write that down, which means Y will be the smaller. Now, every single time I refer to the larger account, I must use X, and every time I refer to the smaller account, I have to use Y. All right, I'm looking for 2 complete independent thoughts. The first one, Kiko has a total of $5,100. Mathematically, what does total mean? Okay, what operation does it tell you to do? Add. So, do you agree that the total means that X plus Y, the larger account plus the smaller account, equals 5,100? Does that make sense? Okay. Now, I need to come up with another equation, and it's hard for me to get the whole thing on there, so I'll move it in just a minute. It says the larger account is 900 greater than the smaller account. The larger is 900 greater than the smaller. If you read it, write it. The larger, what do I write down? X. Okay, the larger is equals 900 more than. 900 plus the smaller. What do I write down for smaller? Y. Don't try to go back up to a previous equation and grab something. Just write down what you read. It said larger, you write down X. Is, you write down equal sign. 900 more than, you write down 900 plus. The smaller, you write down Y. That's why it's so important to name these, so that every time it's referred to, you use the correct letter.
So how do you know which phrase goes to which equation? Like, because I thought that, like, we were still in the same equation. So.
Okay, once I have, when it said the total is 5,100, it has a total of 5,100, that's a complete thought. And so that made up the first equation.
So whatever, it just gives you the total and the sum?
Uh-huh. And you're going to see a variety of ways they do this in these problems. Now, in the interest of us getting through all of these, I am not going to have time in all the problems to solve the systems. And so sometimes I may have to stop a problem early. Now this one, that's all you were asked to do is come up with the system. And it turns out it is this choice right here. That's all you're doing. The next problems 3 through 8, I will not have time to solve all of them. And I'm waiting. There it is. Okay, this is problem number 3. And I want to emphasize to you where we switch from one of the sentences, one of the equations, and get to the other. It says, two numbers total 62 and have a difference of 26. Find the two numbers. Well, the author of the problem has already started things for us. They're saying use X and Y. Now, what do you want to call X? You want to call it the first number, the big number, the first number. Because they never talked about large and small in here. So we'll call X the first one, which means Y is the second one. Okay. It's time to start writing equations. Two numbers total 62. All righty. Total means to add. So X plus Y equals 62. That was the phrase that I have, or the clause that I have in yellow. Okay? They have, and I'm not writing over it because if you were to print this, if you cover it with blue, it disappears. So I just know that, so I just put it over it. The difference is 26. Well, what does difference mean?
Subtraction.
Subtraction. So X minus Y is 26. Now, it's not important in this question, but I just want to ask you, have you designated accidentally maybe one of these numbers to be the large one and one of them to be the small one? The large one is X because you said X minus Y is 26, so X must have been the big one. You didn't necessarily even intend that, but it did happen. It is larger now, just because you put it first in the subtraction. Okay, now we're going to take time on this one to solve this system. We look at this system and it is decision time. We're not going to graph it.
Addition.
Addition. Why do you choose addition?
Because we got the negative and positive.
Yeah, you've got opposites, don't you? So I choose and you choose the addition method. It didn't say X equals or Y equals, which is what I want for substitution. So I choose the addition method, which is 4.3. Add 'em. X plus X is 2X. The Y's are canceling, and that equals 88. Divide by 2, and X is equal to 44. I've got half of it done. Pardon?
62 from 26. You got 44. Yeah.
Yes, but that's just real peculiarity for this problem. Okay, so don't try that. But you did make a good observation. All right, now find y. Which equation? Oh, we have a new 10 o'clock rule, which is pick the first equation. That's not a math rule. That just seems to be the rule in this classroom. Plug in the, whoops, I'm sorry. And I am not able to erase. You're going to plug in the value for x. 44 plus y is 62. Subtract 44. And y is equal to 18. I got answers of 44 and 18. Look back up. Prior to this point, we've been answering our questions about systems as ordered pairs. Up here, it just has blanks. And I hope that their programming allows you to put either one in either place. 44 and
No, Y was 62.
y is not 62. I took the equation. When I started off, the original sentence said the total is 62. Okay? So, 44 and 18. Let's look at number 4. All we're going to do on number 4 is set up the system just because of timing. If you look at the printed notes, I think you'll see it all worked out. It says, a number plus twice a second number is 10. Twice the first number plus the second number totals 8. Find the numbers. How many numbers am I looking for? 2. I will let x be the first number and y be the second number. Now, if the problem had referred to larger and smaller, then I would have called them larger and smaller. But it just called them first and second. Now, please do this as you work through it. Every time it says first number, you write down an X. And every time it says second number, you write down a Y. All right, it starts out, whoops. A first number plus twice a second number is 10. Okay, here I go. A first number. What do I write? X. Plus
2Y.
2y, because it said twice the second, is 10. If you read it, you write it.
Is it okay if I did like Y in parentheses too?
Sure. It sure is. All right. The next part says twice the first number,
2X
2x,
plus
plus the second number is totals 8. And totals just confirms the fact that we did add them.
So we have to find.
Okay, we can get this started if you want. All right, looking at this system, it is not ready for substitution. It is not ready for addition. It has to be modified. So which one do you want me to use? Okay, you want me to, am I going to use addition or substitution? All right, I'd like to use substitution because I haven't done an example of substitution in these lessons. I think I'd like to solve the first equation for x. So, substitution. No, not at all. If you used addition, then you'd have to turn both of these into 2's or both of these into 2's. And if you look at the printed notes that get posted, I do this problem twice. I had enough time in my first class. I did it both ways. Okay, but in here I'm just going to use substitution. If I have x plus 2y is 10, and I want to isolate x, what am I going to have to do? Subtract 2y. Subtract 2y. X is equal to negative 2y plus 10. I'm going to write down the new system, which is a little time consuming. The new system is x equals negative 2y plus 10, and 2x plus y is 8. This is my modified equation, and I'm going to put it in the place of x like I did in the 4.2 lesson. So that's 2 parentheses, negative 2y plus 10 plus y is equal to 8. Distributive property. 2 times negative 2y is negative 4y. 2 times 10 is 20. Plus y is 8. Yes, negative 4y and positive y is negative 3y plus 20 is 8. Subtract 20. Negative 3y. Quit that. Is negative 12. Divide by negative 3. Divide by negative 3. And y equals 4. Out of sight. There it is.
So y is 4?
Y is 4. Now, find x. This I did by substitution, which means if I go back up, do I see a circled equation?
Yes.
So I can use it. I have x is equal to negative 2y plus 10. This is the quick way. So x is equal to negative 2 times 4 plus 10. Negative 2 times 4 is negative 8 plus 10. X is equal to 2. We definitely am going to have to get to number 5, and I'm not even sure how our time is going. Okay. All right, number 5. Do you remember our liquid mixture problems from chapter 2?
100%.
Okay, but in these problems, something that's different is that we're not dealing with 100%. I don't think you're going to find these to be hard at all. Just follow the process. It says, and let me shrink it on the board so I can see the whole thing. It says, Doreen Schmidt is a chemist. She needs to prepare 32 ounces of a 10% hydrochloric acid solution. Find the amount of a 16% solution and the amount of an 8% solution she should mix to get this solution. Now, those of you in the classroom, you really can't read that. It's too tiny. But every time you do one of these, I recommend that you draw the beakers. Okay, my beakers are a little bit big. All right. In these beakers, we no longer, like we had in chapter 2, we're no longer pouring pure acid into something. This one says that we are going to mix a 16% acid solution with an 8% acid solution. And what is it she wants to prepare? A 10% solution. It's the letter F got the word of, the F of.
Oh,
Yes, I misread it earlier in the class. All right, so I've got my little beakers, and now I need to talk about how much of each one. Well, that's the question. How much of the 16 and how much of the 8? So X and Y. Now, the 10%, it tells us how much. If we could read this whole thing, 32 ounces. If you can put all of the information into the picture, you're not going to have any difficulty setting it up. The first part, look at the outsides of the beakers. You have X ounces, you have Y ounces, you pour them together and you get 32 ounces. How would that translate into an equation? X plus Y equals 32. It's always going to be outside number plus outside number equals the outside number. Okay? Now, you want to now talk specifically about the amount of this fluid that is acid. 16% of the X is acid. So we're going to say 16 times X. There's a little decimal stuff that goes on, but we talked about it before. Plus, what? 8Y equals 10 times 32. Every time, what I did was multiply the percent times the outside quantity. And that I will replace with the number 320. Now, because we have very little time left in our class, I'm not going to have time to actually solve this. I'd rather go on to other problems and set them up. If you wanted to use the addition method, you could multiply this top equation by negative 16, and it would be the opposite of that. Or you could multiply the top equation by negative 8, and it would be the opposite of that. If you didn't want to use addition, could you solve the top equation for either X or Y? Yes. If you look at the printed notes, you will see that my first class asked me to do it by substitution, and I did. But we don't have time now. Solve. We don't have time to do that because I'd like to look at another question. And I will read it out loud. It says, recall that two angles are complementary if the sum of their measures is 90. Find the measures of two complementary angles if one angle is 8 times the other. Okay. Now I notice in the question it says small angle and large angle. So I guess I better follow suit and say X can be my small angle and Y can be my large angle. If you just call them 1 and 2, that's okay, but at some point you're going to have to designate one as small and one as large. Okay, 2 thoughts, 2 equations. First thought, these angles are complementary. What does that mean? They're not the same size. It says it right here. No, doesn't say that they're equal if they're complementary. It says their sum is 90. So, X plus Y is 90. That is from the word complementary. X plus Y is 90. Now, it says one of the angles is 8 times the other. Well, which one? Put in the words small and large. Which one is 8 times the other? The large. So I'm going to go up here and where it says 1, I'm going to write the word large. The large angle is 8 times the small angle. So Y is 8 times X. We got one equation from the word complementary, and then we got y equals 8x, and it was important for the y to be right here because the large one has to be 8 times the small one. It doesn't make any sense to say it the other way. What method would you probably use for this system? I would use substitution also, and probably circle this, and it would go in the place there. Number 7. It is another angle problem. It says find the measure of two complementary angles if one angle is 9 degrees more than twice the other, than 2 times the other. Small and large. X is small, Y is large. First equation. These two angles are complementary. X plus Y equals 90. That comes from the fact that they're complementary.
90 or 9?
90.
Yes,
Yes, it stops right there. It says find the measure of two complementary angles if, and now here comes the second statement. One angle is 9 more than 2 times the other. Would you put in large and small here? One angle is 9 more than. Which one am I talking about right here? The large one. The large one is 9 more than 2 times the small one. So how will I write that? The Y equals 9 more than. 9 plus 2 times the small one. 2x. What method would you probably use?
Substitution.
Substitution. Take that for y and put it in right there. Last one. It's another liquid mixture problem. I know you can't read it in the classroom. I'll read it out loud. Somebody named Gabe, a nuclear physicist, needs 80 liters of a 30% acid solution. He currently has a 20% and a 60% solution. How many liters of each does he need to make the needed 80 liters of 30% solution? So here I go with my beakers. Okay.
30, 20 to 60?
All right, we have a 20, we have a 60, and what are we trying to make?
30.
A 30. All right, those are the percentages. Now, how much of each one of these does he have?
X plus Y.
He has X, he has Y. How many of the 30% does he need?
80.
80. So the first thing, if you're going to do this the way I show it, is to get the picture drawn. Because I hope it's pretty clear after that. What's the first equation?
X plus Y equals 240.
No.
Oh.
X plus Y equals, if you're on the outside, stay on the outside.
Oh, 80.
80. Now, we'll talk about 20% of X. So it will be 20X plus 60Y
240.
equals, yes, I'm going to write it first of all as 30 times 80, and that is a little more than 240, is 2,400. Okay, yeah. Then you have to decide whether you want to go with substitution or the addition method. I probably would go with substitution if it was me doing the problem, but that's up to you. I rarely go with addition unless the problem is ready for it. That's kind of my thing. Okay,